welcome Professor Chintan Patel from Electrical Engineering Department, CSET College, Vallabh Vidyanagar. He is now part of CVM University. Professor Chintan Patel has completed his B Electrical Engineering from SVD Vasar in 2001 and completed his ME from BVM Engineering College, Vidyanagar in 2011. He has got gold medal in ME. Presently, Chintan Patel is pursuing PhD from GTU in High Voltage Engineering. Mr. Chintan Patel has 3 years of industrial experience and 15 years of teaching experience. He has published 14 research papers in various international journals and conferences. Research interests are nanodielectrics and electrical characterization of nanocomposites for HV applications. I welcome Chintan Patel sir, and now I will hand over to Chintan Patel sir for the webinar. Yes sir.
Okay, good morning everyone. So good morning, Rajul sir and each and every participant. Today we are going to discuss very briefly constructional and operational aspects of overhead transmission lines. This is what we are going to discuss in today's session. We will be discussing power system basic structure, transmission line components, and how to identify the voltage class of transmission line, that is transmission line identification. We know that today the electricity has become the fourth basic essential of our life, along with food, clothes and shelter. We can't imagine our day-to-day life without electricity. So it is very essential to maintain the reliability of the power supply, and the block diagram shows how can we get the electricity starting from generating station to customer. So the energy is converted from mechanical energy to electricity at all the power plants. Then this electricity is transmitted through overhead transmission network. In most of the cases, it is distributed, and finally the same electricity will be utilized by customers. So at the generating stations, we are converting from mechanical to electrical energy. At distribution or utilization, the same electrical energy is again converted mostly into mechanical energy or heat energy or light. So the question is, if we are converting the electrical energy into mechanical energy, what is the need to generate the electricity at the power plant? The answer is, it is very difficult to transmit mechanical energy at the long distances, whereas the electricity can be conveniently transmitted through thousands of kilometer long transmission lines if it is required. It is very easy to control. It is very efficient to transmit the electricity. That's why we are converting the mechanical energy into electrical energy just for transmission purpose for long distances. Now this we know that there are two types of generation possible, conventional and non-conventional, that is renewable and non-renewable. The transmission systems are of two types, a primary transmission and a secondary transmission. We will see very soon what is the difference between these two. And similarly, there are two types of distribution networks, a primary distribution network and the secondary distribution. This is the basic structure of a power system. Electricity is generated at the generating station in bulk, hundreds of megawatts at certain voltage level based on design of the generators. So these voltage levels are not sufficiently high to transmit the power at long distances, because we know that if voltage is less, then for a fixed power or a constant power, the current flowing through the transmission line conductors will be very, very high. And as the current is high, its immediate effect is the IR and I square R. So the IR is voltage drop in the transmission conductors, and I square R is the power loss. So as the current is high, the IR and I square R will be very, very high. And this will reduce the efficiency of the transmission network. And there are so many problems associated with this. So to decrease the current, the voltage must be increased. And this is done with the help of generating transformer at the power plant. So here you can see the voltage is stepped up from 11 kV to 220 kV with the help of transformer, and from the power plant itself, a 220 kV transmission line is carrying the bulk amount of power. Now, depending upon the requirement, the transmission line voltage may be 132 kV, 220 kV, 400 kV, or 765 kV in the case of AC transmission lines. If it is a DC transmission lines, which is very popular nowadays due to some advantages, the voltage level may be plus minus 400 kV, 500 kV, and 800 kV. So this transmission network with extra high voltage or ultra high voltage level is known as the primary transmission. The primary transmission is the transmission network having the voltage level in the range of EHV or UHV. At the end of primary transmission level, there will be a substation in which the voltage is further stepped down. So from 220 kV to 66 kV in this case. After this stepping down the voltage to 66 kV, another transmission line is started of 66 kV transmission. So this transmission network is known as the secondary transmission network, where voltage is transmitted either from 220 to 66 kV or 132 kV to 66 kV and so on. At the end of secondary transmission network, there will be a primary distribution in which the voltage is further stepped down from 66 kV to 11 kV. And after that, the primary distribution is started. At the end of primary distribution, there is a pole mounted transformer, popularly known as DP, which is available at our society, our institute, and everywhere in the distribution network, where the voltage is further stepped down from 11 to 415 volt 3-phase or 230 volt single phase. And after that, this power is distributed to various customers like industrial, commercial, agricultural, urban, residential, etc. So this is a basic structure of power system. Now, if you notice the basic structure of the power system, very interesting point in this is, in entire this network, only one step-up transformer is used. And this step-up transformer is available at the power plant. Remaining all the transformers are step down transformer. So the important thing here is the transmission and distribution network. The power which is generated at the power plant, it is transmitted through mainly this primary transmission network in a bulk. Bulk means hundreds of megawatts. So it is very essential to design the transmission network in efficient manner. It is very much essential to understand each and every component of the overhead transmission network so that the transmission line can be operated efficiently and the reliability of the power supply can be maintained. And to understand this, to operate the transmission line efficiently, we need to understand each and every component in detail. So in this lecture, I am going to discuss a few components of the transmission network, overhead transmission network. So before discussing the transmission line components, we need to classify the transmission lines. There are three main factors responsible for the transmission line classification. The first one is voltage class. The transmission line is classified based on voltage class. Then second one is based on a number of circuits. And third one is type of current. In voltage class, as we have observed the diagram in the last slide, there are various voltage levels starting from 66 kV to 765 kV in AC. So these are the AC voltage levels, and 400, 500, 800, 1200 kVs, these are the DC transmission line voltage level. In number of circuits, there are three possibilities. First, single circuit line, double circuit line, and multi-circuit line. Whereas in the type of current category, there are two types of transmission networks, HVAC and HVDC. There is one more method to classify the transmission line, and it is based on the distance to which the transmission line is carrying the power. So three types: short transmission line, medium transmission line, and long transmission line. Now, in short transmission line, the distance is generally considered less than 80 kilometers. In medium transmission line, it is in between 80 to 250 kilometers, and in long transmission line, it is greater than 250 kilometers. When we consider the distance for the transmission line classification, we have to observe the area of the power system. For example, you can't compare Indian power system and Sri Lanka power system because Sri Lanka is very small country. Its area is very, very small. So it may be possible that in India, 80-kilometer transmission line is considered as short, but the same length transmission line, it will be considered as either medium or long in country like Sri Lanka or Bhutan. So this distance varies from country to country. Okay. Now our main focus of the talk is transmission line components. So here you can observe one photograph of transmission line tower. This is 400 kV transmission line tower, and in this tower we can observe a few components. Important components of the transmission line are the line conductors, line supports, that means towers. The next is line insulators and cross arms, earth wire, sometimes known as lightning arresters, vibration dampers. These are the essential components, and there are certain tower accessories. So the tower accessories are anti-climbing devices, danger plate, face plate for the face identification, bird guard, power line markers. So we will be discussing each of these one by one. I will show you a lot of photographs taken from the practical power transmission line and discuss the function and features of each components very briefly. So the first is line conductors. We know the function of the line conductors to carry the power or current. Generally, 3 conductors are used for single circuit line and 6 conductors are used for a double circuit line. Now, the usual material for the line conductors are aluminum, and the type of the conductor is called ACSR in most of the cases, which is called aluminum conductor steel reinforced, ACSR. So in the picture, you can observe 2 types of conductors. Let's say this is figure 1 and this is type 2. Type 1 conductor is traditionally used ACSR, aluminum conductor steel reinforced, in which the inner is the steel core, which is used to increase the mechanical strength, and outer strands are circular cross-sectional area of aluminum material. They are used to carry the power or current. In the figure 2 or picture 2, there is a new conductor which is called ACCC. So ACCC is aluminum conductor composite core. In ACSR, as a core, steel is used, which is very costly and bulky. So it increases the overall cost of the conductors as well as weight of the conductor, and as a result, it is sometimes very difficult to handle the conductors. So in place of steel core, in ACCC conductor, the composite core is used, which is very lightweight. Also, there is one more difference between ACSR and ACCC. The cross-sectional area of the outer strands, outer aluminum strands, is trapezoidal. So you can clearly observe the difference that in ACSR conductor there are air gaps or voids, but in ACCC conductor no air gap or no void. So most of the area is utilized, and as a result 28% more aluminum is used. As 28% more aluminum is used, the overall area of the conductor is increased, and as a result we know that R is equal to rho L divided by A. As area is increased, the resistance of the conductor will be decreased, and as the resistance is decreased, its current carrying capacity is increased enormously. So this is very brief about conductors. The next is towers. This is backbone of the transmission line. Generally, steel towers are used, and the main function of the tower is to provide a mechanical support to the line conductors. The tower has 5 main components. If you look at the tower, this part is known as the peak of the tower. Then this middle component is called cage of the tower. These outer components are called cross arm of the tower. The lower component or below the cage, it is known as the body, and there are 4 legs of transmission tower. So there are some other components also I will discuss very shortly. Now let's see which are the various types of towers. So very first type is suspension tower. Now mainly the suspension towers are used where the transmission line is going straight or maximum there is an inclination up to 5 degree. For example, transmission line is going like this. So if here there is a tower, here there is a tower, here there is a tower, all these towers are suspension tower. Why they are called suspension tower? Because these insulators, you can see, they are suspended vertically. So it is suspension tower. But every time it is not possible that transmission line is traveling or running straight. Sometimes it is required to divert the transmission line due to any reason. For example, transmission line is coming from this point to this point, and after this point, it is diverting. So here it is making some angle, let's say theta. If this theta angle is greater than 5 degree, then suspension towers are not used. So for that, the towers used are called either tension tower or angle tower. So in the photograph, you can see transmission line is coming from this side and it is going this side. So here it is making some angle, theta. And as a result, tension tower or angle tower is used. In the photograph, you can observe the line insulators are not suspended vertically, but they are mounted about horizontal axis. So this is the difference between tension tower and suspension tower. This type of towers are used for turning points. In the photograph, you can see one transmission line is coming. It is changing the direction and going further. So these two towers, let's say tower number 1 and tower number 2, these two towers are the suspension tower, and tower number 3 and tower number 4, they are the either angle tower or tension tower. The next type of the tower is transposition tower. We know the transmission lines, the conductors of the transmission line are transposed after certain distance to nullify or compensate the effect of mutual inductances, and this transposition is carried out at tower. So the tower which is used for transposition purpose of the conductor or phases are called transposition tower. In this picture, you can see the transmission line is coming from this side. Let's say this R, Y, and B. This R phase is at position 1, Y phase position 2, B phase position 3. So from this position number 1, this R phase is connected to position number 3. So now from R1 it becomes R3. Similarly, this B and Y position are also changed accordingly. So on the tower, this transposition is carried out is known as the transposition tower. So depending upon the transmission line length, there are transposition towers. The next is a special tower. You can observe something special in this tower, that is its height, its design. This type of special towers are used to cross either river, lake, valley, pond, etc. They can be identified from their gigantic structure and a slightly different design as compared with the conventional towers. So here also you can see the huge structure of the special towers, and they are crossing the river or lake. In this photograph, all the three types of towers which we have discussed earlier are visible. The first, these two towers, obviously they are special towers. The next two types are tension towers. So you can see the transmission line is changing the direction. So these two are the tension towers, and all these towers in the background, which are simply suspension towers. So in the one photograph itself, there are three different types of towers are visible. Okay. Now, further, there are a few types of towers based on their shape. Among them, the first one is waist type tower. So you can see this is the waist as our human being waist. This type of design is used for voltage classes from 132 to 765 kV. The design is very strong. So this type of towers are used for very uneven terrain, uneven region. And generally, two suspension types of insulator strings are used, and the middle line conductors, they are supported with the help of V suspension string. The next is double circuit tower. So here you can, in the this, let's say R, Y, and B, three phases. So only this is the single circuit line. We can say this is the single circuit transmission line. Only three conductors, R, Y, B, three phases. But there are the transmission lines having total 6 conductors or 6 phases. So RYB at one side and RYB at another side. This type of towers are called double circuit towers, and the lines are known as the double circuit line. So obviously the double circuit line can carry more power because the two line conductors, they are the parallel to each other. So overall cost of the transmission line will be decreased and they can carry more amount of power. The voltage range is from 132 to 400 kV, and this is the actual photograph of double circuit transmission line. The next is multi-circuit towers. Now in multi-circuit towers, the number of phases or number of transmission line conductors are more than 6. So if more than 2 circuits are used, they are known as the multi-circuit tower. So you can see here there are total 12 conductors. 12 conductor means total 4 circuits in this transmission lines. So they can carry even more amount of power, and as a result, this type of transmission lines save the space requirement and ROW. ROW means right of way. This type of lines and towers are mainly used in metro cities where the cost of the land is very, very high. Another type of tower which is not used in India, but this is very popular in Western countries, it is called guide V type tower. It is used for 220 to 765 kV transmission line. Design we can see, if you compare this area, this ground area, then it is very, very less. So as compared with earlier transmission towers, whether it is double circuit, multi-circuit or waist type tower, the ground required or land requirement is very, very less. But this is not popular in India. It is used in Western countries. After transmission towers, now let's quickly see the line insulators. The function of the insulator is first to support the line conductors, that means to provide mechanical support to hold the conductors, and second important function is to isolate the conductors from ground. That means isolate them electrically from the ground. There are types of the insulators based on material used for the design. So it is porcelain, silicon rubber, and toughened glass insulator. So based on material, there are 3 types of the insulators: porcelain or ceramic, silicon rubber insulators, they are also known as the composite insulators, and the toughened glass insulators. Insulators are also classified based on structures. So they are pin type insulator, suspension type insulator, strain type insulator, and shackle type insulator. So in the photograph, you can see this is the porcelain type insulator, conventionally used since more than 100 years. This is glass insulator, and the last photograph is of either silicon rubber or composite insulator, which are very new, and they are used since 30-35 years in overhead transmission line. So all the insulators are having their own advantages and disadvantages, but the silicon rubber insulator, this insulator, are having some more advantages compared to porcelain and glass. So all the transmission companies, transmission utilities, they are planning to replace the existing porcelain and glass insulator with silicon composite insulator. So in near future, it may be possible that all the insulator used in overhead transmission lines will be silicon rubber or composite insulator. This is pin insulator used in distribution network. Depending upon voltage class, design may vary. This is how a pin insulator is mounted in the actual distribution network. But then comes the suspension insulator. So you can see two discs which are connected with each other to form the suspension insulator string. Now this disc insulator or suspension type insulator has two main components. The first component, these two are, they are known as the metallic cap. So this is the metallic cap, and this inner part and this lower part, these are known as the metallic pin. So these two are metallic components, and in between two metallic components, cap and pin, there is an insulating material. So in either ceramic or glass. So this is glass. The design is similar. It is believed that the capacity of one disc is 11 kV. So depending upon our transmission line voltage level, we need to connect a number of insulator discs together to form the suspension insulator string. Okay, so this is how different insulator strings are connected together. So you can see metallic joints, and this is porcelain disc, and here it is the glass. This is glass. So this is suspension type insulator with the help of glass and porcelain material. This is composite insulator. The design of the composite insulator is different as compared with the glass and ceramic insulator. In glass and ceramic insulator, we are using the word disc. But in composite insulator, the disc word is not used. In place of disc, the different word is used, which is called weather shade. So here, the inside material or inside component is called FRP rod, fiber reinforced plastic rod, which is used to have the mechanical strength of the insulator. And over this FRP rod, there are silicon rubber weather shade. So in conventional insulator, we are using the word disc. In composite insulator, we need to use the word weather shade. At top and bottom, that means here and here, the metallic fittings are provided to hold the conductor and to mount the insulator on cross arm of the transmission tower. So you can see here, these are the metallic fittings, and in between FRP rod and weather shade. So the number of weather shades may vary depending on transmission line voltage level. So now I will quickly show you how to calculate the number of disc requirement in suspension insulator. Let's calculate for 66 kV. So the transmission line voltage is given 66 kV, line to line voltage. So VL is 66 kV. This line to line voltage of the transmission line it becomes the phase voltage when we consider the voltage across string. So from VL we need to calculate V phase, which is VL upon root 3, because we need to provide the isolation or insulation between conductor and ground. And when we measure the voltage between conductor and ground, it is not the line voltage, but it is the phase voltage, V phase. So if you divide 66 with the help of root 3, you will get around 38.11. So we can approximate to nearest full number, which is 40. Now, as we know, capacity of one disk is 11 kV. So in this case, the total number of disks are required 4. So for 66 kV line to line voltage, only 4 insulator discs are sufficient, not 6. But one disc is added as a safety factor. If something goes wrong with any insulator disc, then for proper isolation, one extra disc is added as a safety factor. So total number of discs required are 5 for 66 kV transmission line. So using this method, you can calculate for 132 kV, 220 kV, 400 kV, etc. voltage lines. So the table shows the number of insulator disc required per string. So for 66 kV, 5 or 6. If you use 2 safety factors, for 132 kV, 8 to 10, and so on. So you may calculate the number of discs. Okay, now let's see different types of insulator strings. So here you can observe 2 types of suspension insulators. In this case, you can see there are 2 strings, and here there is only 1 string. So this is called the double suspension insulator, and on the right hand, this is known as the single suspension insulator. This double suspension insulator having 2 strings are used for extra safety when the transmission line is crossing either road, railway, or any important landmark. So if there is a problem in one string, then the second string will hold the conductor and it can prevent any undesired accidents due to the failure of the insulator string. Single suspension, double suspension, already we have discussed. There is a single tension and double tension and V string. So all these 5 types of insulator strings I have put in single slide. So you can see this is single suspension tower or insulator string. This is double suspension, then single tension, double tension, and this is the V string. 2 insulator strings are connected to hold the conductor, and it is forming the V shape. So it is known as the V string suspension insulator. So there are total 5 types of suspension, 5 types of insulator strings are used in overhead transmission lines. I'm not discussing this because part of distribution network, strain type insulator, so we can easily identify from their mounting. They are mounted generally about horizontal axis. This is pin insulator. Here various components are shown which are used to mount the insulator string to transmission tower. So they are ball clevis, D-shackle, chain link, yoke plate, arcing horn, socket clevis, corona ring or guard ring. If the voltage level is up to 220 kV, it is known as the guard ring, and beyond 400 kV, it is known as the corona control ring. Along with these accessories, a few other important components used in overhead transmission lines are sag adjustment plate and turnbuckle. So we know that depending upon the surrounding temperature and current carrying capacity of the conductor, sag is either increased in generally summer season. So when the sag is increased, we need to adjust the sag so that flashover from line to conductor or from line to any object under the transmission line can be prevented. So to control the sag, either sag adjustment plates or sag adjustment turnbuckles are used in transmission line. There are a few other auxiliaries like ground wire or earth wire, lightning arrestor, breakers, relays, dampers, also used in transmission network. So you can see in this photo two topmost conductors along with three line conductors. So this is R, Y, and B. They are called line conductors. Other than line conductors, there are two conductors which are called ground wires or earth wires, or they are also known as the lightning arrestor. These ground wire earth wires are earthed through transmission tower, or they are connected to ground through transmission towers, and they are providing shielding from lightning arrestor. So when lightning stroke strikes on the transmission line, they receive the lightning stroke and provide the complete conducting path to the ground. So they protect line conductors from any further damage or other consequences. The next is vibration damper. So you can see this device, vibration damper, which is connected near insulator string. It is very important device. As we know, the transmission line conductor is connected between two insulator strings at two towers. So the transmission tower line conductor is like this. There is wind flowing throughout the day, and because of this wind, there are vibrations in this line conductor. And if this vibration reaches, if these vibrations reach to the mechanical joint of conductor and insulator repetitively, it may mechanically damage the joint, and it may cause a severe damage to the transmission line. So to prevent this, a vibration damper is used. This vibration damper is nothing but it is a specially designed weight which is suspended. So when vibrations come from the line conductor through this end, this vibration damper will absorb all the energy of the vibrations, and it prevent vibration strike to the insulator and conductor joint, thereby protecting the mechanical joint. So this is very important device from transmission line point of view. Another component of the transmission line you can see is the guard ring. Generally, guard ring is used to improve the string efficiency and to improve the potential distribution across the insulator string, so that the electrical stress to the nearest insulator disc can be minimized, thereby minimizing the risk of disc failure. So it is a guard ring. Now there are different shapes of the guard ring, and they are used based on voltage class. This is jumper. Generally, jumper is used where the tension towers or angle towers are there in the transmission line. So various size and shapes of the dampers are visible in these photographs. The weight of the damper is selected based on voltage level, possibility of the wind speed, etc. So these are various vibration dampers used in overhead transmission lines. Okay. The next component is very important. It is known as the cone shape component you can see they are called the bird guard. Now, what is the function of the bird guard? Let's assume bird guard is not provided. So here, if this bird guard is not provided, any bird, it sits here, and the dropping of this bird may be deposited on surface of the insulator. So if the droppings of the bird deposited on the surface of the insulator, and if this absorb the moistures, it will create a conducting film. So this will create a conducting film on surface, and it may be the cause of surface flashover. So to prevent the surface flashover, the bird dropping should not be deposited over the surface of the insulator. And to do this, it is advisable that birds should be prevented sitting at this position. So how can we do that? Simply provide this cone shape of device, which is called bird guard. So this bird guard will prevent the sitting of bird exactly at this location. Bird is free, or birds are free to sit anywhere, here, here, here. They can sit, but not exactly over the string. And for this reason, bird guard is used. So in this photo, we can see guard ring. So this is the rod type of guard ring. Simply two rods are used with spherical end. Earlier guard ring was U-shape. If you recall, this type of guard ring was used. In this case, 66 kV transmission line, rod type guard ring is used. A few other components are earthing wire. So these topmost wires are earthing wire or ground wires, cross arms, and danger plate. Danger plate is used for the warning to the people that what is the voltage level, and this voltage level is very much dangerous for human being. So this type of danger plates are used at all the transmission towers. The next is the phase identification plates. They are called the phase plate. So you can observe here, this is the yellow color plate and this is the blue color plate. I am not sure whether it is visible or not to you because very small component, but this type of phase identification plates are used so that we can understand which one is the R phase, Y phase and B phase. Nowadays, so in this diagram you can see here there is a bird guard. So bird guard and phase plates are used. Nowadays there is an innovation. New type of combination is used. Phase plate and bird guard both are same. How? In this photograph you can see. This is bird guard as well as phase plate. Actually this cone is colored in red, yellow and blue. So they are serving two purposes. They are working as a bird guard as well as they are also working as phase plate. So no separate phase plate is used. Only bird guard is provided with the different color R, Y, B. The next is the spacers. Now the spacers are used in the overhead transmission lines where the bundle conductors are used. Bundle conductors. We know what is the bundle conductors. The bundle conductors are the conductors in which more than two conductors are used per phase. So here you can see two conductors are used per phase. So in each phase there are two conductors. Bundle conductors are used mainly to reduce the corona in UHV or EHV transmission line. And to keep a proper distance between two conductors, the line spacers are used. So you can see this is the spacer. This is the photograph of bundle conductors. Here 2 conductors per bundle, 3 conductors per bundle, here 4 conductors per bundle, and here 6 conductors per bundle. In India, Generally, bundle conductors are provided in transmission line in 400 kV or beyond that. So if the line voltage VL is more than or equal to 400 kV, bundle conductors are used. So generally in 400 kV, 2, 3 and 4 conductors per bundle per phase are used. These are the spacers. So spacer for 3 conductors, spacer for this is also for 3 conductors. This is the spacer for 4 conductors per bundle. So this is very special component. If you travel by express highway toward Ahmedabad, there is one 400 kV line, and in that transmission line, the topmost conductor consists of this type of balls. This type of balls. These type of balls are known as the power line markers, or simply they are known as the line markers. There are various colors visible from distant place, and they are used as identification mark. Now, this type of power line markers are used in the transmission line passing by area where nearby there are airports, or maybe there are airports, or the area having the low fly zones. If it is a low fly zone, like Kashmir, when Army and Air Force aeroplanes are flying frequently, it is low fly zone. So in near airport or low fly zones, there must be some identification that at certain place there is a transmission line. Otherwise, there may be accident between transmission line and aeroplane or helicopters. So this type of power line markers are used, which are visible from a distant place, and pilots of helicopters and aeroplane can identify that there are transmission lines at certain distance. So to prevent the accident, line markers are used. There are 2 types of line markers used. First, the normal line markers, which are visible, and the another line marker is the self-illuminated markers, because during night time the normal spherical markers will not be visible. So there is a provision of illumination. You can see the photograph. You can see orange color and size of the power line marker. It is provided at certain height. Now here it is a self-illuminated marker. The self-illuminated marker consists of LED. And this LED will be glowing from a simple circuit which generates its own power from electric field or magnetic field. And this type of self-illuminated markers are visible even during night period. So this is very essential device and is used in India also. Next component is bird diverter. So this bird diverter is very important device, and it is frequently used in Western countries. There are migratory birds. Birds which are flying from one area to another area depending upon weather conditions. And these migratory birds fly in huge quantity, a large quantity. So they may collide with the transmission lines, and there may be a potential damage to transmission line as well as birds also. So to prevent these bird diverters are used. This type of markers are provided on the conductor, and these are visible from distant place. So the bird can identify that certain object is there, and they will change their elevation. This is another type of bird diverter. It is free to rotate, and you can see different designs of bird diverters. Radiant colors are used so that they are visible from a long distance, and observing this, the group of the bird, pool of the bird will change the elevation to prevent the collision. So this is the bird diverter. There are some other auxiliaries. I am going quickly because we are running out of time. It is anti-climbing device. There is a fencing. So you can see this type of fencing is provided to prevent anybody or even monkeys and other to climb the transmission tower and to prevent the accident. Now, how can we identify the voltage level of transmission line? So one method already we have discussed by counting number of discs. But if it is a silicon rubber insulator or composite insulator, then it is difficult to count the number of discs. Or if the transmission line tower is located a very distant place, then also it is not possible to count exact number of discs. So there are certain methods to identify the transmission line voltage levels. First method already discussed, so I'm not repeating, based on number of insulators, disc in string. The second method is based on shape of the guard ring. For example, this is simply a road type guard ring, and it is used up to 132 kV transmission line. So if you see any transmission line, first of all, try to count the number of insulator discs, and based on that you can identify the voltage level. Then you observe the shape of the guard ring. If it is road type, then simply 66 kV or 132 kV transmission line. Then either U type or this C type guard ring is used beyond 132 kV. It may be 220 kV transmission line. This type of guard ring is used. And in UHV transmission lines, that means 400 kV and 765 kV transmission lines, the ring type corona ring is used or guard ring is used. So observing the guard ring shape, you can identify the voltage level. The next is tower shape. By observing the tower shape and number of earth wire, you can identify voltage level. So up to 220 kV, the number of earth wire will be 1. Only one earth wire is used up to 220 kV. So if only one earth wire is used, and depending upon number of disc and guard ring, you can easily identify the voltage level. But if there are two earth wires, topmost two earth wires, then certainly it will be 400 kV or 765 kV transmission line. Then distance between conductors and ground clearance. It is certain difficult, but with certain practice, you can easily identify the voltage level from distance. And finally, number of conductors per phase. That means whether it is simple line conductors or bundle conductors. In India, up to 220 kV, simple conductors are used, and beyond 400 kV and beyond 400 kV, bundle conductors are used. So if it is a bundle conductor, then definitely in 90% cases, it will be 400 kV line, because we have very few 765 kV transmission lines. Near Parul University, you will find 400 kV line and 765 kV line both. So now let's quickly identify the line voltages. So as I said earlier, this is H pole tower. Number of discs are 5. Only one conductor is used. So certainly it is a 66 kV AC transmission line. So here H pole tower is used, and here simply the tower structure, lattice tower structure is used. But still this is 66 kV transmission line. Now compared to earlier, number of discs are more. You can see number of discs are more, and shape of the tower, height of the tower is also more than the previous slide. So this is certainly one step ahead of 66 kV, and one step ahead is the 132 kV transmission line. So this is 132 kV transmission line. Next, here number of insulator discs are more, you can see, and shape of the guard ring. Observe the shape of the guard ring. In earlier photo, you can observe the shape of the guard ring here. It is simply rod type, but in this case, it is the U type, inverted U. And number of discs are more. Height of the tower is also more. The distance between two conductors is also more than the previous case. So certainly it is more than 132 kV, and in India, more than 132 kV line is 220 kV line. So this is 220 kV line. You may also observe this topmost earth wire. So only one earth wire is used. So it is 220 kV line. Next, there are so many identification marks. First, two earth wire 1, earth wire 2. So 400 kV line. Shape of the guard ring. It is ring type. So 400 kV transmission line. Bundle conductors. More than one conductor per phase. So bundle conductors. 400 kV lines. Number of insulator disc. Obviously more than 220 kV. And size and height of the tower. So all these identification marks are clearly indicating that this is 400 kV transmission. Next, this is also 400 kV transmission line. All the identification marks, you can see two earth wire, guard ring, distance between two conductors, bundle conductors, number of insulator disc, etc. Next, this is gigantic structure. This photograph I have taken near Parul University. Once I visited Parul University, at that time I have taken the photograph. It is of 765 kV transmission line. So you can see two earth wire 1 and earth wire 2, gigantic structure. So it is a gigantic structure. Then 4 conductors per bundle, 4 conductors. Number of insulators disc and height of the tower, shape of the tower, and distance between two conductors. All these are saying that this is certainly 765 kV transmission line. So now whenever you visit the Parul University after the completion of pandemic, you try to find out all these identification marks in 400 kV and 765 kV transmission line. This is also 765 kV transmission lines with waste type of tower. Next one. This is really a gigantic structure, and it is of 1200 kV transmission lines. So there are 6 conductors per bundle, 6 conductors. This is the transmission tower of a newly 1200 kV transmission line, which is under experiment by Power Grid Corporation of India Limited in Madhya Pradesh. The name of the substation is Bina. The power line is doing experiment on 1200 kV line, and this is the photograph of 1200 kV line. These are the two, this is the pole of circuit breaker, SF6 circuit breaker in substation. So you can see the structure size of the each and every component. This is another transmission line. In all earlier transmission lines, we have observed 3 line conductors. But in this case, there are only 2 line conductors. And the 2 line conductors are used only in HVDC line. This is 800 kV HVDC lines. And now they are called the poles. So this is pole 1, pole 2. Here also there are 2 poles. Maybe same polarity or different polarity. This is the photograph of 800 kV transmission line from China. The next, it may be 1200 kV HVDC transmission lines. So This is how we can identify the voltage level of transmission lines. So I stop here. If you have any query, you may write the question so that we can discuss briefly.
Sir, please provide your email ID so that if possible they can queries can be sent to you.
Okay, so my email ID Chintan Patel @gset.ac.in. So if you have any query, any question regarding what we discussed today, you may contact to my this email ID.
Uh,
Okay, so thank you.
so this was good information provided by Chintan Patel sir. And if any viewers have any query, they can write to his email ID. I thank Mr. Chintan Patel for giving such a good information on this transmission line towers and this transmission network. And I hope that it is very much useful to my 7th sem students, which is a subject they are going to study in this next semester. So, sir, I convey my thanks to you on behalf of Electrical Engineering and Department Purdue University.
Thank you. Thank you very much. So thank you very much, Parul University, for inviting me. Hope students learn something from my presentation. Thank you.